Hello, welcome to WMW's weekly newscast, bringing you the global waste management headlines. Coming up, how burned bacon inspired microwave-induced pyrolysis recycling system at Cambridge University. Viridor is to proceed with a 30 MW waste gasification plant in Scotland. The US EPA tours a dry AD plant in San Jose. And in Taiwan, an old master breathes new life into discarded glass. Cambridge University has published a video explaining how a burned bacon sandwich led to the development of microwave-induced pyrolysis process that is being used for recycling laminated packaging to recover aluminium and fuel. Here's how it works.
I'd heard about the over-microwave bacon roll from an acquaintance at Cambridge, and I was intrigued by the possibilities. And I was wondering whether the pyrolytic process could be used to recover value materials from packaging wastes. We had one particular type of packaging in mind, the type of plastic aluminium packaging that's commonly used for drinks pouches and cartons, toothpaste tubes and pet food pouches.
Plastic aluminium laminates are widely used because they actually tick a lot of boxes in the sustainability list. They are very light, they are very good for transport. As a consequence, they have very few resources embedded in the material. However, the last box, the recyclable box, was so far on tick. And this is what the MW technology allows. The MW technology allows these materials to become recyclable and therefore tick that last box that brands were looking to tick. Before we developed the MW technology, most of the plastic aluminium laminate used in packaging ended up in landfill, or in the best case scenario, in energy from waste. But the important bit is that the aluminium was not recovered.
Like the original experiment, they take carbon in the form of granular particles, add the laminated packaging, replace the air inside the oven with nitrogen, and then microwave at 600 degrees Celsius. The laminated material separates into clean aluminium flakes and hydrocarbon gases and oil, both of which are collected and used to power the plant.
Viridor is to go ahead with its planned 30 MW waste gasification plant in East Lothian, Scotland. Colin Patterson, Scottish Regional Manager at the firm, explains more.
So today we're announcing that final approval has been given for Viridor's new £177 million energy recovery facility at Dunbar in East Lothian, which marks the next stage in our ambitions to deliver a £1.5 billion worth of investment in recycling and renewable energy infrastructure across the UK. Our portfolio of recycling and renewable energy sites across the country will be critical to ensuring that we translate the ambitions of Scotland's zero waste agenda from policy into practice. In tandem with our existing £100 million network of Scottish infrastructure and recycling projects, this project will help to divert residual waste that would otherwise be destined for landfill and turn it into a valuable energy resource that will be connected to the national grid and will help power the equivalent of 39,000 homes. In addition, the site will also provide up to 10 megawatts of renewable heat for local use.
In the US, the EPA has published a video looking at a new food waste processing facility in San Jose. Jared Blumenfeld, Regional Administrator for the agency's Pacific Southwest region, tells us more.
Right behind me is San Francisco Bay, and between me and the bay is compost that came from food scraps. This is an incredible project here in San Jose, California. The project's been up and running. It gets food scraps, but all kinds of stuff from the commercial sector. It puts it through this dry anaerobic process. What comes out the other end is energy and really great compost. So it's kind of like magic. Hard to believe they do it with so few moving parts, but it's really revolutionary. And the coolest thing is, really can be done anywhere. So this is a model for many parts of California, but also the rest of the nation. How we can turn food scraps. Amazing to me that 25% of all the fresh water in the United States goes to making food that's then thrown right away.
In Taiwan, a celebrated glass artist is recycling 100,000 tonnes of glass waste every year to produce both works of art and energy-saving building materials. Here's more.
For these works, most of the raw materials have come from WU's integrated waste glass recycling facility. In fact, WU has always maintained that the recycling of waste glass not only makes good business sense, but is also good for the planet. According to WU, silica sand accounts for 60 to 70% of the content of glass, and his team recycles more than 100,000 tons of waste glass every year. This means a reduction of up to 70,000 tons of mining ore, as well as a significant reduction in borax and the import of alkali and other materials.
For WMW, I'm Ben Messenger. Thanks for watching.